Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into the 11th grade topic, amplitude and frequency of trig functions. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 3 parts, so leave a like, smash subscribe, and let's get started! So the first thing we're going to need when we're talking about amplitude and frequency of our trig functions, more specifically our cosine and our sine functions, is going to be the general formula for our trig. So I'm going to start with the sine one because it's pretty much the same as the cosine, but I got to start somewhere. And it's going to be a sine of bx plus c plus d. Now, a in this case is going to control our amplitude. B is going to control the period and the frequency. C is going to control, in this case, our sine moving across the x-axis. How are we going to go left and right? D is going to be how we're going to be going up and down. Well, I guess C is not really the x-axis because this is radians or degrees. How is it going to be moving left and right on the radian or degree axis? Well, D is going to be moving up and down our value axis. For this video, we're not concerned with either C or D. And quite honestly, this is probably going to be the most familiar to you because we've been doing this for non-trig functions all along. How we move it left and right on the x-axis or up and down along the y-axis. That's going to function in the very same way as the C and D. So for this video, A and B are going to be our star players. So we said A controls the amplitude. Well, what's going to be the amplitude? What's our formula for the amplitude? Well, the amplitude, I'll say amplitude, is going to be, quite honestly, the absolute value of whatever that A is. That means it doesn't matter if A is going to be negative or positive, our amplitude is always going to be a positive number. Whatever that A is, you take the absolute value and that's our amplitude. So that's our amplitude. Now let's move on to this B. We said that this B is going to control both the period and the frequency, which lets us know that period and frequency are somehow related. Well, what are the formulas for period and frequency? Period, I'll just mark it with a P, is going to be this 2 pi over whatever that B is, except it's going to be the absolute value of that B. Period is going to be 2 pi over the absolute value of whatever this B is. And our frequency, I'll just denote that with an F, is going to be the reciprocal of this period, which means it's going to be the absolute value of that B over 2 pi. So you see, in fact, they are indeed related. One is the reciprocal of the other. And since they're both related, I'm going to cover both of them together a little bit later. But first, let's jump into what this amplitude actually is and how does it affect our graphs. Well, here we have the graph of our basic sine function. Now, if you have any questions about how to graph sine functions, the basic one, or your cosine functions, I recommend you pause this and then check out my previous video on how to graph your trig functions, your basic trig functions. Because today we're going to be manipulating the basics. We're going to be straying a little bit away from the basics. I don't want to confuse you, especially if you don't necessarily understand how to graph the basics. So check out that video and then come back here before we start manipulating our basics. But here we have the basic sine function. If I was to ask you the amplitude of this basic sine function, what would you tell me? Well, remember, our general formula was a sine bx plus c plus d, right? And we didn't really care too much about the c or the d, but we said this a, if we found the absolute value of that a, that's going to be our amplitude. Well, what's a in this case for a basic sine function? A is going to be 1. So technically, we have the absolute value of 1. So our amplitude is 1. So we can say our amplitude is 1. But what if I ask you about sine of x, but instead of having a basic one, we put a 2 here? What if I did this? What is our new amplitude? Well, in this case, our amplitude will be 2 because that's here. It's positive already, so we don't have to do anything because the absolute value of a positive number is still that same positive number. 2 sine x is going to give us an amplitude of 2. But what is the amplitude? This shows us how we can easily find it, but we still don't know what it is. Well, in this case, our amplitude is going to be how we're stretching our trig functions. Or shrinking too, it could be shrinking, but how we're manipulating the stretching or shrinking of our trig functions. If you have an amplitude of 1, notice that the highest that your sine is ever going to be is that 1. And the lowest it's ever going to be is the negative of that amplitude, 1. Negative 1, right? So if we have a new amplitude because we have a new number in front, our highest is going to be this new amplitude. The amplitude is how far you are away from 0. You are 2 away from 0. Likewise, you're going to be 2 away from 0 this way. So you're going to be down to -2 here. So this amplitude controls your min and your max for your trig functions, specifically your cosine and your sine functions. So if we had, instead of 2 here, if we had 5, well, our amplitude is going to be 5. And our max is now going to be 5, and our min is now going to be -5. Amplitude just stretches or shrinks. Now, you've seen it stretch. You haven't seen it shrink yet. Well, shrinking just means that instead of having a whole number here, we have a fraction. Our amplitude is now a fraction. You can have a fraction here. And that just means that instead of having this here, our highest point is actually going to be 1/2. And our lowest is actually going to be -1/2. So it doesn't matter if you're a whole number or a fraction, your amplitude is going to see how far are you stretching or how much are you compressing your trig function. Now, I'm not going to cover this being a negative because it doesn't affect the amplitude. Remember, our amplitude is going to be the absolute value of that a. So if this is a negative, it's not going to change the amplitude. The amplitude is going to be the same as if it was negative or positive. But it does affect the graph, but that's not something we want to cover in this video. Just know your amplitude is going to be how much you're stretching or shrinking your trig function. And it's going to be a vertical stretch or shrink. I just wanted to make sure I highlighted that because you can think that we're stretching or shrinking horizontally, but that's going to be what we're going to be talking about next. Well, here we have our graph of our basic cosine function, and that's only because we did sine in our previous example. So we're going to be focusing on cosine here. It's the same thing. You can do it for sine or cosine. I'm just focusing on cosine for this example. This is going to be our basic cosine graph. Notice we have one full cycle from 0 to 2 pi. And our highest point is going to be 1, and our lowest is going to be -1. This is just cosine of x. But if I asked you to tell me what the period and the frequency was, you can use these formulas here. Remember, this is going to derive from our general formula here for cosine. And we would know that our period, because b in this case is 1, our period is going to be 2 pi, and our frequency is going to be 1 over 2 pi. But just like amplitude, that doesn't tell us what that is. We know how to find it, but we don't know what it is. What does a period mean, and what does a frequency mean? Well, the period is going to be what is the distance it takes before your graph starts repeating itself. So you see the period is going to be 2 pi. That means that our entire graph is not going to repeat itself until it hits 2 pi. We're going to be a unique graph with no repeats until 2 pi. After 2 pi, you're going to do the same exact graph again. So it tells you your graph is not going to repeat until you've hit 2 pi. So that's our period. Well, frequency is going to tell us a very similar story, just using different words. So frequency is going to be mainly focusing on how fast or slow our function is going to be oscillating. So this says 1 over 2 pi, which means we're doing one oscillation every 2 pi. So one oscillation going from start to start every 2 pi. So you see your period and your frequency are going to be roughly saying the same thing, just in a slightly different way. And this is going to be true for cosine of x. But what if we have cosine of 4x? How is that going to change anything? Well, notice for cosine of x, we went 0, pi, and 2 pi. Our pi was our lowest, and our 0 and our 2 pi were both our highest. How is cosine of 4x going to differ? Well, what's the period here? Well, the period is going to be what? So we'll say period is going to be this 2 pi over the absolute value of 4, which is just 4. So 2 pi over 4, which is just going to be pi over 2. So if the period is pi over 2, that lets us know that we're going to repeat after pi over 2. So this means our graph will end up looking like this instead. So we're always starting here at the 0, but this is pi over 2 because our period is pi over 2. This is going to be pi over 2, which means that this is pi over 4. Very different, very different. We're not going the same 2 pi here. We're having one full oscillation at pi over 2. We're very, very squeezed. We're squeezed here because we're fitting in one oscillation in a much smaller range. How about our frequency? What is our frequency here? Well, this is going to be reciprocal. So that's going to be 2 over pi. That lets us know that our graph at a high level, we're expecting 2 full oscillations every pi. 2 full oscillations every pi. And if you look at it here, we did 1 oscillation at pi over 2. Do the same thing, we're going to get to pi, and that's 2 full oscillations. So if we were to compare this cosine 4x to cosine x, and we know our frequency is we're going to be doing 2 full oscillations every pi, well, how does that match up with this cosine? By simply comparing the frequencies, we have 1 over 2 pi for one, and we have 2 over pi for the other. Well, if you're going to compare them, we have to have like denominators, right? So this is just going to be 4 over 2 pi. So if this was 1 oscillation every 2 pi, that's what cosine x was, we're going to have 4 oscillations every 2 pi for cosine of 4x. That means this thing is going to be oscillating 4 times as fast as our basic cosine function. But we can actually slow down our oscillations as well by not having a whole number, but instead having a fraction here, just like we did for amplitude. So we have this 1/4 here. How does that affect our period and our frequency? Well, our period is going to be 2 pi over this 1/4. And whenever you divide by a fraction, you multiply by the reciprocal. So this is really going to be 2 pi times 4, which is going to be 8 pi. And our frequency is, of course, 1 over this 8 pi. So with a period of 8 pi and a frequency of 1 over 8 pi, we can fill out our graph to be this. 1 full oscillation happens every 8 pi. This is a very, very slow moving graph. It's not moving that fast or not oscillating that fast at all. 1 full rotation is happening every 8 pi. That's what our frequency says. Before we repeat, we have to go the full 8 pi. That's what our period says. So if we were to compare this cosine of 1/4 x to our basic, we had 1 over 2 pi frequency. This is 1 over 8 pi. That means in order to compare this like basis, we have to have 8 pi here, 4 up top. That means our original is going to be moving 4 times as fast, or oscillating 4 times as fast as this new function here. So this is how you're going to be able to find your period and your frequency, and you can see how it's affecting your graph, and you can even see how you can use frequencies to compare your trig functions. So I hope you were able to follow in today's video, and I hope you now know how you can find your amplitude, frequency, and periods of your trig functions, and you can even see how they affect your graphs. However, if you have any questions about what you saw today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping to help with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.